Common workflow is to read your data into a data frame, then reduce this data frame to the particular columns or rows that you're interested in working with. As you've seen, the Pandas toolkit tries to give you views on a data frame. This is much faster than copying data and much more memory efficient too. But it does mean that if you're manipulating the data, you have to be aware that any changes to the data frame you're working on may have an impact on the base data frame you used originally. Here's an example using our same purchasing data frame from earlier. We can create a series based on just the cost category using the square brackets. Then we can increase the cost in this series using broadcasting. Now, if we look at our original data frame, we see those costs have risen as well. This is an important consideration to watch out for. If you want to explicitly use a copy, then you should consider calling the copy method on the data frame first. In this course, we'll be largely using smaller moderate-sized data sets. As I mentioned, a common workflow is to read the dataset in, usually from some external file. We saw previously how you can do this using Python and lists and dictionaries, and you can imagine how you might use those dictionaries to create a Pandas data frame. Thankfully, Pandas has built-in support for delimited files such as CSV files, as well as a variety of other data formats including relational databases, Excel, and HTML tables. I've saved a CSV file called olympics.csv, which has the data from Wikipedia that contains a summary list of the medals various countries have won at the Olympics. We can take a look at this file using the shell command cat, which we can invoke directly using the exclamation point. What happens here is that when the Jupyter Notebook sees a line beginning with an exclamation mark, it sends the rest of the line to the operating system shell for evaluation. So cat works on Linux and Macs as well as in the Coursera platform, but might not work on Windows. You don't need to worry too much about this. I just wanted to show how a Jupyter Notebook can integrate with the operating system to provide you with even more tools to look at your data. We see from the cat output that there seems to be a numeric list of columns, followed by a bunch of column identifiers. The column identifiers have some odd-looking characters in them. This is the Unicode numero sign, which means number of. Then we have rows of data, all columns separated. We can read this into a data frame by calling the readCSV function of the module. When we look at the data frame, we see that the first cell has an NaN in it since it's an empty value, and the rows have been automatically indexed for us. It seems pretty clear that the first row of data in the data frame is what we really want to see as the column names. It also seems like the first column in the data is the country name, which we would like to make an index. readCSV has a number of parameters that we can use to indicate to Pandas how rows and columns should be labeled. For instance, we can use the index call to indicate which column should be the index, and we can also use the header parameter to indicate which row from the data file should be used as the header. Let's re-import that data and set our index value to be 0, which is the first column, and let's set our column headers to be read from the second row of data. We can do this by using the skip rows parameter to tell Pandas to ignore the first row, which was made up of numeric column names. Now, this data came from the all-time Olympic Games medal table on Wikipedia. If we head to the page, we could see that instead of writing gold, silver, and bronze in the pages, they used nice little icons with a 1, a 2, and a 3 in them. In our CSV file, these were represented with the strings 0, 1 space, exclamation mark, 0, 2 space, exclamation mark, and so on. We see that the column values are repeated, which isn't really good practice. Pandas recognized this and appended .1 and .2 as appropriate to make things more unique. But this labeling isn't really as clear as it could be, so we should clean up the data file. We can of course do this just by going and editing the CSV file directly, but we can also set the column names using the Pandas name property. Pandas stores a list of all of the columns in the .columns attribute. We can change the values of the column names by iterating over this list and calling the rename method of the data frame. Now, I'm going to copy and paste this in to speed up things, but we can walk through what is going on here. Here we just iterate through all of the columns looking to see if they start with a 01, 02, 03, or numero character. If they do, we can call rename and set the column parameters to a dictionary with the keys being the column we want to replace and the value being the new value we want. Here we'll slice some of the old values in too, since we don't want to lose the unique appended values. We'll also set the ever-important in-place parameter to true so Pandas knows to update this data frame directly. All right, that's more on the data frame with a focus on the workflow of actually getting data in and into a place where we might want to query it.